Hi, welcome to Team Healthcare Wizards. My name is Vin Lee, and our team consists of four members: Miles Shipman, Alan Nichols, June Park, and myself. Our programmers are Miles Shipman, Alan Nichols, and June Park. I am the project manager. The goal of our project is to create a simple and quick heart rhythm analysis tool that will provide points of atrial fibrillation. The heart rhythm graphing prototype we designed uses simple ECG EKG data from MIT, but given enough time, the tool would allow patients to upload their own data. For now, patients' information are downloaded from GT Fire server. This project has been a great team experience because all team members has equally contributed in the areas of their specialty to the project, making this a successful project that is on time and on target with goals and objectives. At the current time, our team does not have any future plans on expanding beyond the scope of this project. However, beyond this course, we have discussed the possibility of adding the features for patients to upload their own ECG, EKG data and creating a service that can interface with patients' cardiologists to retain the history of their EKG, ECG reading and perform notification of any atrial fibrillation. On this slide, I have provided our task list on the left and a Gantt chart on the right. This will provide you with a better view of our team contribution. As I have mentioned from the previous slide, all team members have contributed equally in the areas of their specialty. Our team have done a great job with staying on target to meet the timeline. As of now, all the tasks listed below has been completed. To summarize our final project, during the planning phase, our entire team participated in every task together because this was the early phase where we had to brainstorm to design the project idea. The presentation for this phase was presented by Alan Nichols and myself. During the design phase, the architecture design was put together by the entire team. The screen layout was prepared by Alan Nichols. The external system tools and dataset design was prepared by the team. The presentation for this phase was presented by Miles Shipman and myself. For the development phase, June Park completed the web page design and jQuery to FireScript. Miles Shipman completed the ECG EKG data conversion. Alan Nichols completed the D3.js to showcase the .text and .csv data and the algorithm for the analysis of heart rate data. I have prepared the presentation and narrative. Together, I have presented the presentation with June Park. Finally, for the implementation phase, I have worked on the brief narrative for the project overview and final Gantt chart. Alan Nichols completed the project detail explanation. June Park completed the development plan, while Miles Shipman completed the demo of the application. For the GitHub submittal, everyone took part in preparing the documents. The final presentation was presented by everyone on the team.
We decided on the heart rhythm visualization tool because we wanted to give patients a simple way to visualize their heart rhythm data. More patients are using at-home heart rhythm monitors and more patients want ownership of their own health data. Our tool allows patients to visualize and to analyze their own heart rhythm data. For our research, we interviewed a cardiologist named Dr. Nichols. He told us that atrial fibrillation is one of the leading causes of strokes in the United States and that these risks can be prevented with a pacemaker. He told us that there is a need for patients to monitor their own heart rhythms at home because fibrillations can occur at any time and must be recorded and verified before insurance companies pay for a pacemaker. For our research, we also used multiple heart rhythm analysis, published papers, and several JavaScript publications describing how to plot data with D3. The functionality of our tool is that it allows patients to upload their own recorded heart rhythm data, have it analyzed for irregularities, visualize it on a navigable graph, and see their own health records in Fire. Furthermore, all the analysis is stored in simple JSON structure so that our tool has the added functionality of an API itself, so that other plugins or modules could be created in the future to further analyze the data. The usability and design of our tool was a primary goal. We wanted to make the interface simple and intuitive for patients to use at home. The tool uses the jQuery and CSS Bootstrap themes so that it matches the look and feel of the Fire interface. Our tool is a web app and it works in both desktop browsers and smartphone browsers. Our heart rhythm analysis and visualization tool is innovative because patients are not currently encouraged to hold on to their own health data. Currently, a patient must go to their doctor and use an expensive Holter monitor to record 24-hour heart rhythm recordings. Then the patient goes back to their physician where the fibrillation might or might not have occurred during that duration. By recording their data at home and analyzing it with our tool, patients will save both time and money.
For smooth final product deployment, we will follow this deployment plan. First, we will set up Tomcat web server for our product to run on. Then, we will try to install our product. Once the installation is done, we will verify the installation. That is, all the necessary libraries, JSON database files, and actual project files such as JSP and JavaScript files must be installed on the web server. After the verification, we will turn the server on and we will run some quick tests for deployment verification. If all the test cases run successfully, then we will confirm the deployment is over.
Welcome to the demo portion of our presentation. In front of you is what the website looks like deployed and how the user would see it when they first load it. At the top, we have a navigational bar, followed by our patient select. Normally, this would actually be replaced by the ability to load files. However, for the sake of this project and for the sake of time in demoing, we decided to have 9 patients pre-selected and loaded for the use of a proof of concept. Followed by that, we do have a simple set of instructions for the first-time user, followed by our graph area, and then finally our patient information area. If we go to the top of the navigational system, we do have an About section. The About section tells you who we are, what the goal of our project was, and why we started and why we attacked this project and decided to develop this application. Following that is more technical information of where we got our EKG data for the purpose of demoing, what type of defects we are looking for in our heart rhythm analysis, how we're using FHIR, and then finally the heart rhythm JSON structure. The JSON structure will return vital information back to the application, such as the sample rate, the diagnosis, the heart rate, the rhythm rate, and then finally the QRS list, which shows the QRS defects or QRS heart patterns, the peaks and the slopes. Now, if we go back to our visualizer, we can select a patient. And as we see, we could select a patient here. Patient 100 is a diagnosis of normal heart rhythm with a heart rate of 74 beats. Finally, when we do pull this up, it does populate the patient information. It also populates the QRS information based on the peaks of heart rhythm. Now, if we go to patient 101, we'll see heart rhythm atrial fibrillation. Now, there is a slight bug with how our algorithm calculates heart rhythms that sometimes reports the wrong heart rhythm. And then finally, it produces new patient information and new QRS data on the side. The QRS data on the side represents defects detected by the algorithm. So if we select a defect, we'll be looking at position 46045 in the heart rate. Heart rate 4065 would be some divisible second number once it's divided by its sampling rate of 360 samples per second. Now, when we select that, the graph is automatically created showing 45 seconds of data before the detection of the defect and 15 seconds of data after that defect. The defect itself is actually highlighted in red. Now this initial graph can be a little hard to take in. It's a lot of data points. So what we've implemented to help is the ability to zoom in on the graph, which sometimes can be a little bit of a hassle. There we go. Trackpads do not like zooming. So if we zoom in on the graph, we can actually zoom in on our data and look at everything around it. We can zoom out, we can zoom in. We can also scroll to the left and to the right with our data so that we can know where it is. Thank you.